Hello and welcome to the Unit 4 Section 3 video on finding slope from 2 points or a table. So in the last section we talked a little bit about what slope is, how to determine it from a graph. It's our change in y and over our change in x, and that is really going to be the key here to finding the slope between 2 points, is that equation that we went over before, which is our change in y over change in x, which is y2 minus y1 over x2 minus x1, where x1, y1 is a set of coordinates, x2, y2 is your other set of coordinates. So the first thing you're going to want to do is label which point is going to be which. And it doesn't really matter which is which, just as long as your x1 and y1 to go together and your x2, y2 go together. So after you label them as such, so I'm going to do that here. So we have x1, y1, and x2, y2. So after we label these, we are going to draw the division bar, and we're going to put in the minus sign. Okay, so slope, just so you know, a letter that we use for slope is m. So I'm going to start using m for slope. Our slope m is going to be our y2 minus y1 over x2 minus x1. So let's draw our division bar, and let's put in our minus signs. Then we're going to fill in the blanks. So y2 is 2, y1 is 7, x2 is negative 14, x1 is negative 12. So the important thing here is, the reason we put our minus signs in first is because we have to keep that minus sign here even though this is already negative. So another thing to keep in mind here is the numbers in the ordered pairs should line up vertically in the formula. So our x2 and y2 are 2 and negative 14. They line up vertically. Our 7 and our negative 12, they line up vertically. And then from here, we're just doing math. We have 2 minus 7 on the top. Negative 14 minus a minus gives us a plus 12 on the bottom. And so 2 minus 7 is going to be negative 5. Negative 14 plus 12 is going to be negative 2. And our negatives will cancel, so our slope is going to be 5 over 2. So now that we've seen how to do this, let's do a few examples, because this is basically all of the new content for this section. So let's find the slope, starting off with a set of ordered pairs. So for this one, we're going to let this be x1, y1, x2, y2. So our slope, if we draw our division bar, put in our minuses, y2 is going to be negative 6, y1 is going to be negative 12, x2 is 15, and x1 is negative 11. So we have negative 6 plus 12 over 15 plus 11. So negative 6 plus 12 is going to be 6. 15 plus 11 is going to be 26. And we can reduce that. We know that 2 is going to go into both of these numbers, so 2 will go into 6 3 times. 2 will go into 26 13 times. And that's as far as we can reduce it. So our slope is 3 over 13. All right, for the next one, we have x1, y1, x2, y2. So our slope here is going to be, put on our vertical bar, put in our minus signs. y2 is 5, y1 is 5, x2 is negative 19, x1 is 18. And so 5 minus 5 is going to give us 0. And it doesn't really matter what's on the bottom here, but for the sake of finishing the problem, we're going to have negative 37 on the bottom. But this ends up just being 0. So our slope here is 0. And you know your slope's going to be 0 if your y's are the same value, because they're going to end up subtracting from one another. Okay, one more set of points here. So we've got x1, y1, and x2, y2. So we have our slope being our vertical bar, or our horizontal division bar in our minus signs. y2 is negative 4, y1 is 2, x2 is 16, x1 is 0. So we've got negative 4 minus 2, that's negative 6. 16 minus 0 is 16. And we can reduce that. We know 2 goes into both of them, so we're going to have negative 3 over 8. 6 divided by 2 is 3. 16 divided by 2 is 8. All right, for the tables, you're going to handle a table just like you would a set of ordered pairs. Only difference here is that you can pick whichever 2 coordinates you want to go with. Okay? So we kind of did this a couple of sections ago when we were determining if it was linear or nonlinear. The number we were counting in between, well, that was our change in x, and that was our change in y. So now we can do it using our formula. So we're going to do it this way. So let's make this our 1s and make this our 2s. You could choose any 2 you want. I like to use the numbers I feel like are going to make things easier. So our y2 is going to be 12. Our y1 is going to be 6. Our x2 is going to be 4. And our x1 is going to be 2. 12 minus 6 is 6. 4 minus 2 is 2. And 6 divided by 2 gives us 3. So our slope is 3. Here, we have zeros involved. Let's use zeros because that's definitely going to make our lives easier. So let's use this one and this one. So let's draw our division bar, our minus signs. Our y2 is going to be negative 8, y1, 0. x2 is going to be 2, x1 is 0. Well, anything minus 0 is that thing, so negative 8 over 2, which is negative 4. And finally, for this one, let's do, just for fun, let's do 1 here and 2 here and see what we get. So we're going to draw our bar here. Our minus signs, y2 is 5, y1 is 2, x2 is 10, and x1 is 4. 5 minus 2 gives us 3. 10 minus 4 gives us 6. So our slope is going to be 1/2. Just to show you that it doesn't matter which one you pick, let's go and make this one 1 and this one 2. So our slope ends up being, see, our 1's stay the same, so we can put 2 and 4 here. Our y2 is 4, and our x2 is 8. So 4 minus 2 is 2. 8 minus 4 is 4, and again, we get 1/2. Just to show you that you can pick any set of ordered pairs you want. That is, if they do tell you that this table represents a linear function. All right, let's wrap up this section by finding the slope of these linear functions. Now, we have done graphs already, and we have done that by doing rise over run. But you can use what these ordered pairs are to find what your slope is. So if you wanted to, you could do one set of points being -3, -1, and the other set of points being 2, 2, and put that into the slope formula and find it. But typically on a graph, your easiest way of doing it is going to be by counting your rise over run. So whenever you are presented with your choice of methods, always go with the easier, okay? So we have a rise of 3 and a run of 1, 2, 3, 4, 5. So our slope here is 3/5. All right, let's check out this one. We have a rise of 1, 2, 3, 4, but that's going down, so that's going to be -4 over 1, 2, 3, +3, so -4/3. And then here we have a rise of 1, so that's m equals 1, over a run of 1, 2, 3, 4, 5. So our slope is 1/5. So you probably have noticed by now, when we're looking at graphs, the closer our number gets to 0, the more horizontal it becomes. Because remember, a horizontal line gives us a slope of 0. The closer we get to vertical, the steeper we are, the higher the number our slope is going to be. All right, let's do a couple more examples where we have to use our slope formula to find the difference between our points. So for this one, our y2, in fact, I can show you that it doesn't really matter which way we go. So let's make these our 2's and the second ones are 1's, okay? So we're going to do 20 minus 13 over -8 minus 20. So 20 minus 13, that's going to give us 7. -8 minus 20 gives us -28. And 7 will go into both the top and the bottom number, so we end up with -1/4. 7 goes into 7 once, 7 goes into 28 4 times. For the next one, we're going to have -3 minus -12 over 17 minus 9. So that's going to be -3 plus 12 over 17 minus 9. So -3 plus 12, that is going to give us 9. 17 minus 9 is going to give us 8. So our slope is 9/8. And then finally, last example for the section, let's do 4 minus 16 over 16 minus 0. That's going to give us -12 over 16, and that reduces down to -3/4. So once you get the hang of it, it really is not that much work to find the slope when you're given 2 points, or if you're given a table, you can just use 2 points off of that table to find it that way. All right, so that wraps up this section on finding the slope between 2 points and on a table. Coming up in the next section, we're going to start using the information that we have, such as slope, to graph lines.